Welcome to numerical analysis course. In this lecture we will keep on studying Newton's forward interpolation method. We are given a data table, and the data table is in a form that we are given x and y is f of x, and we are supposed to find the value of y for an x that lies in between any two given values of x. So we have to find this y. Given this x, we have to find the corresponding y. This is what we call interpolation, the value of y that lies in between the two given values of y in the table. Right. For that we studied Newton's forward interpolation method yesterday, and the formula is this. Let's call it x naught, the value of x for which we are supposed to find y. Let's call it x naught, and the corresponding y would be y naught. Actually, we are supposed to find this y naught. Right. This y naught is f of x naught, and Newton said that the formula would be this, and this keeps on going for as many terms as you want. Starts with f of xp, where xp is the base value, the value that is just before this value. For example, for this case, the base value is 1891. Right. And p is xb, the base value, minus the value of x naught. In this case, that would be 1895 minus 1891 divided by the interval width. We studied yesterday that Newton's forward interpolation method is for the case where we have equal intervals, means the difference between any two values of x in the data table is the same. Right. So actually this is 1921 instead of 1925, to keep the difference equal to 1 in all the cases. Right. And xp is the base value just before the value of x naught, and del to the ny, we compute these values from this table that we draw here. The first two columns of this table are drawn from the data provided, and the next columns are computed as the difference of the values of y. For example, this del y, the first term, we write it in between the first two terms of the second column, and it's the difference of the second and the first term. And this 15 is the difference of the third and the second term, and we keep on going. And we apply the same rule on del y, the third column, when we compute del squared y. Right. And we keep on computing unless we are left with only one term in the last column, and we stop there. We stop there at del to the 4y because we are left with only one term. Right. So we are asked to find f of 1895, that is somewhere between 1895 and 1901, the first two values of x in the data table. Right. To find that, let's compute p first. P is xb minus x1. The base value is x naught minus xb. In fact, this is x naught minus xb, not xb minus x naught, x naught minus xb. X naught is 1895 minus 1891 divided by the difference. The difference is 10 throughout, so this comes out to be 4 over 10. It comes out to be 0.4. So this is the value of x in the data table just before x naught is xb. We have already computed that. It's 1891 in this case. And del and y's are computed from the table. So now we are in a very good position to find it. F of 1895, f of 1895 We'll work with f of x b, where the b is 1891 and f of that is 46, plus b is 0.4 times del y, and del y's are computed, we studied yesterday, along the diagonal of the y. So del y is 20 plus p into p minus 1, 0.4 into 0.4 minus 1 del squared y. The del squared y term is negative 5 here, plus p into p minus 1, 0.4 into 0.4 minus 1 into 0.4 minus 2 divided by 3 factorial, and I have missed 2 factorial here, 2 factorial, 3 factorial del cube y. The del cube y term is 2, so this is 2 plus the last 0.4 times 0.4 minus 1 times 0.4 minus 2 times 0.4 minus 3 is 0.4 divided by 4 factorial times del to the 4y is minus 3. So if we solve it, f of 1895 comes out to be 54